Hello everyone, Ramya, Assistant Professor of CSC Department from Rogani College of Engineering and Technology, subject code CS3501, Compiler Design, Unit 3, Topic Types and Declarations, Translation of Expressions. Types and Declaration. Type checking uses logical rules to reason about the behavior of a program at runtime. Specifically, it ensures that the types of the operands match the type expected by an operator. Translation applications. From the type of a name, a compiler can determine the storage that will be needed for that name at runtime. Type expressions. Types have structure represented using type expressions. A type expression is either a basic type or is formed by applying an operator called a type constructor to a type expression. The sets of basic types and constructors depend on the language to be checked. The array type int of 2, 3 can be read as array of 2, array of 3 integers each, and written as a type expression array of 2, array of 3 integer. This type is represented by the tree. The operator array takes two parameters, a number and a type. Type expressions. A basic type is a type expression. Typical basic types for a language include Boolean, char, integer, float, and void. That means it denotes the absence of a value. A type name is a type expression. A type expression can be formed by applying the array type constructor to a number and a type expression. A record is a data structure which named fields. A type expression can be formed by applying the record type constructor to the field names and their types. Record types will be implemented by applying the constructor recorded to a symbol table containing entries for the fields. A type expression can be formed by using the type constructor. For function types, we write s tends to t for function from type s to type t. Function types will be useful when type checking. If S and T are type expressions, then their Cartesian product S into T is a type expression. Products are introduced for completeness. They can be used to represent a list or tuple of types. We assume that X associates to the left and it has higher precedence than arrow mark. Type expression may contain variables whose values are type expressions. Type equivalence. When are two type expressions equivalent, many type checking rules have the form. If two type expressions are equal, then return a certain type else error. Potential ambiguities arise when names are given to type expressions and the names are then used in subsequent type expressions. The key issue is whether a name in the type expression stands for itself or whether it is an abbreviation for another type expression. Declarations. A simplified grammar that declares just one at a time. This is the given for grammar for the declaration. The above grammar deals with the basic and array types. Non-terminal D generates a sequence of declarations. Non-terminal T generates basic array or record types. Non-terminal B generates one of the basic types int and float. Non-terminal C for component generates strings of 0 or more integers. Each integer is surrounded by brackets. An array type consists of a basic type specified B followed by array components specified by non-terminal C. A record type or the second production for T is a sequence of declarations for the fields of the record, all surrounded by curly braces. Sequence of declarations. Languages such as C and Java allow all the declarations in a single procedure to be processed as a group. A variable offset is used to keep track for the next available relative address. This is a given example for the sequence of declarations. The translation scheme deals with the sequence of instructions of the form TID where T generates a type before the first declaration is considered. Offset is set to 0. As each new name exists seen, X is entered into the symbol table with its relative address set to the current value of offset, which is then incremented by the width of the type of X. The semantic action within the production D tends to T. D1 creates a symbol table entry by executing top.put. Here top denotes the current symbol table. The method top.put creates a symbol table entry for id.lexim with type t.type and relative address offset in its data area. Translation of expressions. An expression with more than one operator like a plus b into c will translate into instructions with at most one operator per instruction. An array reference a of ij will expand into a sequence of three address instructions that calculate an address for the reference. Operations with expressions. The syntax directed definition builds up the three address code for an assignment statement S using the attribute code for S, attribute address, and code for an expression E. Attribute s.code and e.code denote the three address code for S and E respectively. Attribute e.address denotes the address that will hold the value of E. This is the example for the translation of expressions. The last production E tends to ID has the semantic rule which defines E dot attest to point to the symbol table entry for the instance of ID. Let top denote the current symbol table. Function to get top dot relatives retrieves the entry when it is applied to the string representation ID dot lexi. The semantic rule for E tends to E1 plus E2 generate code to compute the value of E from the values of E1 and E2. Here the values are computed into newly generated temporary names. If E1 is computed into E1.add and E2 into E2.add, then E1 plus E2 translates into T equal to E1.add plus E2.address. E.code is built by concatenating E1.code, E.code and an instruction that adds the values of E1 and E2. Thank you.